Okay, so this is 1.3. This is how not to do statistics. And so we just got done talking about in 1.2 experimental design. What are some key vocabulary words? And in this section, we take a look at maybe factors that may be inappropriate when you're setting up your experimental design, sort of red flags to say, hey, maybe this data isn't quite as clean as it could be, okay? And so here are a couple of those things. Now, there's nothing really specific about these. These aren't specific definitions, but they're just kind of areas of concern if you want to notice this. So if you're reading a research article about an experiment that was done, you want to take a look at funding. Who funded the experiment or the study? It's probably no surprise that tobacco companies funded studies that showed that nicotine was completely healthy and did not cause cancer. And it's only later that we find out, and this is the classic example, we find out that actually it does cause cancer and that nicotine can become an addictive substance. And so always take a look at who's putting up money for this study. 9 out of 10 dentists recommend this brand of toothpaste. I wonder who ran that study. Was it an independent double-blind study done by the American Dental Association? Or was it maybe a toothpaste company? Could be, I don't know. And so look for who's paying the bill for the experiment or the study that's being done. Also look for variables and like confounding variables, variables such as age, gender, genetic composition, geographic area. Right? If you're looking at a study and it is only focused on a small geographic area, you want to say, is this a good representation? Are the conclusions that they're drawing applicable to people outside of that geographic area, right? And so look for other variables that may account for or may be the reason why certain things happen in the study. Be careful of overgeneralizations, making comments about a specific group of individuals, looking at gender, ethnic groups, age groups. I hear a lot of this stuff about how millennials are lazy. And I went out and I did a Google search on this, looking for articles that were providing evidence that this millennial generation, they're just lazy. They don't want to work. They want everything handed to them. That's an overgeneralization. In my experience, millennials have been very hard workers and eager to get into the workplace. So, be careful of overgeneralizations. Or boomers are out of touch with everything in society. Like boomers, come on, boomer, you don't know what you're talking about. I've found some baby boomers who are usually people 60 and above kind of know what they're talking about. They have a lot of experience. And so be careful of overgeneralizations that are made in statistical studies. Here's another good one, cause and effect. So this graph comes from a website called Spurious Correlations, and it shows the number of tornadoes in the United States from 2002 to 2010. And the tornadoes are the red line, and the axis on the left describes the tornadoes, a minimum of 941 tornadoes up to a maximum of 1,819 tornadoes. The shark attacks are the black line, and their graph is on the right axis between 0 and 3. And if you scale these graphs correctly, notice how they kind of lie right on top of each other. They are highly correlated. The number of tornadoes goes up and the number of shark attacks go up, and the number of tornadoes go down, the number of shark attacks go down. Is there something going on here? Maybe Sharknado actually was a documentary and not a work of fiction. You ever think about that? Maybe Sharknado was actually true. So this is kind of an interesting website, and you want to be careful. Just because two things are correlated doesn't mean that there's causation in there. And here's the website. You can go to this. I'll actually drop this in the chat if you want to take a gander at it. This is called Spurious Correlations. And what the author did is he went out and found data sets and found correlations between arbitrary things. And so going through these, a lot of them are related to death because it's easy to get records about how people died. And so you'll notice that. But here's an interesting one. The divorce rate in Maine, the divorce rate in the state of Maine correlates at a 99.26%. That is an extremely strong correlation. It correlates with the per capita consumption of margarine. Now, why is that? Let's put on our tinfoil hats and see if we can come up for a reason why these two things would be so strongly correlated. Can you think of one? Maybe type it in the chat. Maybe you have a couple that's married and one of the people go out for work. They work hard all day long and they come home and the significant other is sitting in front of the television with a tub of margarine, just shoveling it in. And this person thinks, maybe I could do better. Maybe I could do better than this. Or you have people that are, newlyweds, they're just married. And one of the people get up in the morning and they decide to make pancakes. And so they put a little dab of margarine, in the pan to make the pancakes, and they start making the pancakes. And the other significant other comes down and says, "Oh, what are you doing?" And you say, "Well, I'm making pancakes." With what? Well, with margarine, of course. Oh, no. I don't eat pancakes that are made with margarine. I only eat pancakes that use butter. Oh my gosh, fight ensues, divorce, right? And so sometimes when you look at this data, it's fun to put on your tinfoil hat, right? And use your imagination to come up with what possible reason could there be that margarine and the divorce rates in Maine are correlated. Maybe, I know what it is. The government is putting a secret ingredient in margarine that when you ingest it, it makes you irritable and really a mean person. And therefore, that's why the divorce rates go up, because as people consume more margarine, they consume more of the secret molecule that the government's putting in the margarine to make you more irritable. And that's the cause, right? Let me see. Margarine in the chat. Margarine destroys the human spirit. Yep, there you go. Margarine is full of chemicals, setting couples. That's the same tree I was barking up. Yeah, that idea, right? So it's kind of fun to let your imagination loose, right, and come up with these reasons why these two clearly causal items might have a causation, right? We can sort of imagine a causation, and this is fun. But what if we change the topic? What if we change the topic to, vaccination rates of children in cases of autism? Whoa, wait a minute. Now you're talking about something that's personal to a lot of people. Do vaccines cause autism? Well, if you look at the data, they are correlated. As vaccinations have gone up, cases of autism have gone up. Does that mean there's a cause there? Does it mean it's causal? Is it like the divorce rates in Maine and margarine? Or is there something there? And you have to be careful when you see data of putting on a tinfoil hat and making up a causation when there's none there. No one will argue that there's a correlation, just like there's a correlation between the divorce rates of Maine and the consumption of margarine. But is there causation? And this is where data is often used, or I should say misused, because people will say, well, if there's a correlation, there's got to be causation. And that's not always the case, okay? And you can pick a number of hot button topics, just flip through the local newspaper, or I should rather say, go to Twitter or Instagram or any other social media platform, and you will find it littered with data that is being misused to represent causation. Is there a correlation? Yep, absolutely. And we can mathematically show that there's a correlation. Is there causation? Be careful. Be careful with that causation stuff, right? Because divorce rates in Maine and the consumption of margarine, I don't know, maybe there is a molecule in the margarine that the government's putting in there to make you more irritable, right? I don't know. I'm not going to consume a tub of margarine to find out. But if you want, you can go through and browse this website. It's actually kind of fun to go through and see some of the things that are related, that have very strong correlations, okay, but not necessarily causation. So be careful of cause and effect. Be careful of saying that two things are causal when in fact maybe they're only correlated, okay? Other things to look at: sampling errors. So maybe there was an error in the instrument used to sample whatever it is that you're measuring. Okay, so if you're measuring maybe the temperature outside, maybe there was an error. Maybe the thermometer you were using to do the measurements happened to be next to a heating vent, and that threw off. Okay, so you could have a sampling error. You could also have a non-sampling error, which is maybe somebody made a mistake inputting the data into a spreadsheet, or the formula that was used to calculate certain numbers was incorrectly entered. Maybe they needed to use a 32, but instead they swapped them and put a 23 in there, something like that, right? Those are non-sampling errors. And then looking at statistical significance versus practical significance. And there were a few people had commented this in the textbook reading. And one of the examples that I thought up was, statistically speaking, you are safer to travel by helicopter than you are traveling by automobile. A higher percentage of people get killed in automobile accidents than get killed in helicopter accidents. So to promote safety, we're going to recommend everyone fly a helicopter to work. No, like that's probably not, that does not have practical significance, right? Statistically, is it significant? Oh yeah, totally makes sense if you're trying to find a safer method of transportation. Statistically speaking, yes, but practically, no, it's probably not going to work. Okay, so be careful of trying to, again, jump the shark, if you will, of spanning between statistical significance and practical significance. Okay, then we walk through and we give you a bunch of examples of this. And then finally, a couple last things to look for. Watch for the wording of the questions. Watch and see, is the question worded in sort of a clever way where it paints you into a corner to make a decision that maybe you're not comfortable with? Yes, no questions are kind of like this. Do you support all of the policies from this specific political party? Yes or no? And you're kind of like, well, I support like 80% of them, but I really don't agree with a couple of these positions. So it's not really a yes, no question, right? Wordings of questions often create something called a false dichotomy, a false choice, meaning you either are yes or you are no, and there's no in between. You're either red or you're blue, right? You're either Republican or you're a Democrat. And actually, the truth of the matter is, most of us are in the middle. Most of us are shades of purple rather than pure red or pure blue. And so be careful of questions that sort of give you a choice. You're either with me or you're against me. No, I'm kind of with you on these topics, but maybe not on these one or two, okay? Also, watch out for the ordering of questions. Sometimes the way that questions are laid out as you proceed through them will kind of lead you down a path to a conclusion. So for example, the first question may ask about topic A, and then the next question provides sort of negative information about topic A. And then the question after that provides a little bit more negative information about topic A. And by the time you get down to the bottom of the list where they say, do you support topic A? You're like, well, not after you showed me all this negative information about it, right? So be careful about the ordering or the sequence of the questions. Non-response, this is when not a lot of people respond to the survey. So if I were to, ask what's your favorite coffee, and I surveyed all of West Shore students and only 5% of the students replied, would I feel very confident taking that information to the cafe and saying, here's the favorite coffee voted by West Shore students? Probably not, because only 5% responded, right? And so you want to be careful of surveys that have a very low response rate. And again, it's not that it's wrong or that it's right. There's just not a lot of evidence there, right? Like, I'm not very confident. And I think that's one thing that you're going to find in this class, is that answers aren't wrong or right. there are various shades of correctness, right? There's various shades of how confident you are that a question is correct or that a response is correct. And what we do is we tease apart and we say, okay, what level of confidence should we have in order to proceed on something? 80% confidence, 90% confidence, 95% confidence. And we're going to show you how mathematics can be used to establish that. So it's not just kind of an arbitrary number. We'll actually show you reasoning built in behind that. A couple others real quick: voluntary response. So voluntary response, if you work in the food service business, who fills out comment cards? Usually not the happy customers. It's the customers that had a bad meal, right? So if you served 100 customers in an evening and 3 comment cards were filled out, they're probably all negative comment cards about people complaining, right? And so you have to look at people that are filling out a survey because they have a specific interest, right? They have just kind of like an interest. They have almost like a hidden agenda in order to reply, right? And if the survey doesn't meet, or they don't hope to get something from the survey, then they don't fill it out. Okay. And so you have to be careful of voluntary responses. And so a few examples of this, and then we're done. We're done with 1.3. Okay. So let's jump into the Google assignment for 1.3. And in this Google assignment, what we do is we give you the 100 random numbers that we talked about earlier, and we just ask you to find the mean, the median, and the mode of these 100 numbers. And so when you click on this assignment, the spreadsheet pops up. You've already got the 100 numbers there. And again, if you click on any random cell or any empty cell and hit the delete key, it will re-randomize all those numbers. And so you just go down here and you enter the formula, like if we do the mean, so equals AVERAGE, that's the average. And then we're going to highlight the data set and hit enter. And that will give us the average, the mean of all these 100 numbers. And then as I refresh, you can see the 100 numbers refresh, and the calculation of those 100 numbers, the mean, also refreshes. Okay. And so a nice thing about the spreadsheet, one more thing that I want to show you about the spreadsheet, and it's included in the very first part of the instructions. We talk about named ranges. So when you're looking at a data set like this data set, and you notice that when I created this, I said equals average, and then I highlighted these cells. So I highlighted this orange block of cells. One nice thing about Google Sheets is that you can actually give that group of cells a name. So you don't need to keep highlighting the cells. And that's what I'll show you how to do right now. So I'm going to go into my spreadsheet, and I'm going to click on the 100 random cells. So I'm highlighting these 100 random cells, and I'm going to go to data, and then I'm going to scroll down to named ranges, and I'm going to click on that. And when I go to named ranges, it says, okay, these are the cells that you've highlighted, B1 to K10, and give it a name. So I'm going to call this set of cells Pete. So there we go, that's Pete. And so now any calculation that I want to do referencing these 100 cells, I can just use the name Pete. So if I go down here again to the mean, I'm going to replace this B1 colon K10 with Pete. And it calculated the mean of Pete. I can then go down to the next set of cells, and I can say for the median, I'm going to say equals median of Pete. And the spreadsheet knows that Pete is those 100 cells. Finally, I'll do the mode, equals mode of Pete. And there's the mode. And again, if I re-randomize all of these, those numbers change automatically. So where would this be helpful? Let's say that you have a data set that includes information about a veterinary clinic and the weights of different animals. So let's say that These cells are the weights of the dogs that came in. So I could go in, I could say data, named ranges, and I could call this dog. And we'd be done with that. And then let's say these are the weights of the cats that came in. I know it doesn't make sense because 97 pounds for a cat is kind of heavy, but I don't know. I guess maybe it could happen. Data, named ranges, we're going to call this cat. And then these are the weights of what? We've got dogs, we've got cats. What else do we need? What else goes into the veterinary clinic? Dogs, cats, lizards. I don't know. Is there a large lizard? We'll call it Liz, L-I-Z. Okay, there we go. So if we wanted to find the mean of the dogs, we would just say equals average and then type in dog. And you see how it highlights those cells? It says, oh, I know dog are these cells. And so you could actually go through and do average of dog, average of cat, average of Liz, and it would use the appropriate cells. And so naming your data sets is kind of, I don't know, I think it helps students, I don't know, like not remember the data sets, but it makes it a little bit more personable than just B1 colon K10, right? You can give it a name and you can say, what is the average of Pete? And it will find it for you. So pretty cool.